Hi, in this video we want to learn about SI units and metric system. So here are the learning objectives. At the end of this lesson, we can list fundamental SI units. What are fundamental SI units? We can find derived units of quantities. We can use metric prefixes and we can convert units. So why do we need to use numbers? Before learning about units and numbers, let's see why do we need to learn them. The first step to understand the universe is observing. We observe and we describe. An object is far, big, very big. But the problem is these words cannot help us to understand about the size and magnitude. We cannot communicate about size of an object by saying it's very big. So we need numbers. And numbers are not enough. If we are told the distance between point A and point B is 40, that doesn't make any sense. We need units, we need scales. 40 watt, 40 meters, 40 kilometers, 40 centimeters. So we need to agree about units. So we needed one system of units. We have 7 fundamental units. SI system of units. S is standing for system and I is standing for international. It is a French term. So we have 7 units, and when I say the length of something is 2 meters, anyone anywhere in the world knows how much that is. In AP Physics 1 we will work with these 4. These 2 will be in AP Physics 2, and this one is not in AP Physics. So unit length, the symbol of length is L. Unit is meter, is not kilometer or centimeter, is meter. And the symbol of meter is M. Mass, kilogram, is not gram, is kilogram. And symbol of mass is kilogram is kg. Time, the SI unit for time is second, and symbol is S. Symbol of time is T, symbol of mass is M, and electric current, symbol of electric current is I. Unit is ampere, and symbol of ampere is A. Temperature, Kelvin, and amount of substance is mole. The reason that these 2 are capital is because they are name of scientists. Ampere is name of scientist. Kelvin is name of scientist, so we write it with capital letter K. But if we write it with capital Kelvin, capital K, here we are talking about the scientist Kelvin. If we want to mention the unit, we use small k. So small k, when we write the whole word as unit, capital K for unit of temperature. So that is all we need, 7 units. Whether you want to send a rocket to space or analyzing the motion of electron, that's all we need. And all other units, which we call them derived units, are based on these 7 units. If you simplify them, finally you reach to some of these units. There is another system of measurement which is called American system, but it's not used as much as SI units are used. Only 1 or 2 countries use this system. sometimes. And for example, for length, they have different units: um, inch, foot, yard, feet, mile. For mass, pound. For temperature, it's Fahrenheit, it's not Kelvin. But in here we mostly work with SI system in AP physics. So what is meter or kilogram, second? The definition of these units changed over time. For example, 1 meter used to be a bar, a platinum bar kept in Paris, but it has changed. Right now, it's a definition. It's the time, it's the distance that light travels in a fraction of time. The only unit that is defined based on a physical object is kilogram. So 1 kilogram is mass of platinum cylinder which is kept in Paris, and one version is kept in Washington, D.C. So derived units. We had 7 fundamental SI units. All other units in physics are called derived units. And we can find them by knowing those 7 fundamental units. We can find unit of any other quantity. For example, here I want to find a unit of area, SI unit of area. You can think of a rectangle or a square. Area of a square is length times length. Unit of length from that table was meter. So meter times meter. So unit of area, SI unit of area is meter square. For volume is length times length times length. It's meter cube. For speed is distance. SI unit for distance, this is a fundamental quantity, is meter. Time was second. So for speed is meter per second. Velocity also, displacement, SI unit for displacement is a fundamental unit, is meter per second. Acceleration is changes in velocity over time. Velocity was meter per second, and time is second. So unit of acceleration is meter per second square. Force is mass times acceleration. Mass was a fundamental unit, kilogram. And acceleration, we just got it here, is meter per second square. So unit of force is kilogram meter per second square. And all of that is called Newton. Capital N, because it's a name of a scientist. Or you can write it as Newton. Small n because we're talking about the unit Newton. Metric prefixes. SI units are a part of metric system. For example, kilogram, which is SI unit of mass, it's a fundamental unit. K is standing for kilo, and kilo means 1000. So 1 kilogram means 1000 gram, or 10 to the third. K, kilo, 10 to the third grams. Or 1 kilometer means 10 to the third meters, means 1000 meter. Or 1 millimeter, milli means 1 over 1000. means 10 to negative 3 or 1 over 1000. So 1 millimeter means 10 to negative 3 meters. This the first M is standing for milli. The second M is standing for meter. So we need to know these prefixes. We see some of them more, like giga, mega, kilo, centi. Centi means 1 over 100. 1 centimeter means 1 over 100 meters. Micro and nano, pico. We see these prefixes more often. One easy way to remember these symbols and prefixes is paying attention to the first letter. So after mega, mega means 10 to the 6th. Megabyte, 1 megabyte means 10 to 6 byte. 1 gigabyte means 10 to 9 byte. 1 terabyte means 10 to 12 byte. So after mega, we use capital letter of first prefix. M, capital M. G, capital G. After mega. Before mega, smaller than mega, all are small letters. And just the first letter, K, H. For deca, we use D, the first and the last one, DA, deca. Why? Because we have deci, which is started with D. We don't want to confuse these two. So for deca, D, A. For deci, 1 over 10 or 10 to negative 1, D. Centi, milli, M. Micro is this, nu. So we cannot use a small m because it's for milli. Capital M is for mega. So we come up with a new letter, mu, for micro, 10 to negative 6. Nano, pico, femto, atto. So here we want to convert these units to SI units. 500 grams. We know that SI unit of mass is kilogram, not gram. And 1 kilogram is equal to 1000 grams. Kilo means 1000. So 500 gram is 0.5 kilogram. 2 hours. We know that SI unit for time is not hour, is second. So 1 hour is 60 minutes, and each minute is 60 seconds. So 7,200 seconds. 3 megagram. So 1 mega is 10 to the 6th. 3 times 10 to the 6th grams. We know that 1 kilogram is 1000 grams. So we need to divide this by 10 to the 3rd. 3 times 10 to the 6th divided by 10 to the 3rd kilogram, and that's equal to 3 times 10 to the 3rd kilograms. 300 kilometers. We know that SI unit for distance is meter, is not kilometer. So 1 kilo means 1000, 300 or 10 to the 3rd meters. 4000 centimeters. Centi means 1 over 100. And meter is SI unit. It's what I want. So 4000 times 1 over 100 meter is equal to 40 meters. 55,000 millimeters. Milli means 1 over 1000 or 10 to negative 3. And meter is SI unit for distance. So this one is equal to 55,000 times 10 to negative 3 meters. That's equal to 55 meters. Suppose that you drive Suppose that you drive 10 kilometers from university to home in 20 minutes. Calculate average speed in kilometers per hour and meter per second. Meter per second is the SI unit. So average speed is distance over time. Distance was 10 kilometer divided by 20 minutes. So this is equal 10 over 20 is 0 0.5. 0, 3 significant figures, kilometers per minutes. We want to change it to kilometer per hour. Kilometer doesn't change. We know that 1 hour is equal to 60 minutes. That's what we know. So what we do, we multiply this to another fraction. Here we want to get rid of minutes, so we write minutes up here so we can cancel them. 60 minutes is equal to 1 hour. Basically, we multiply this to another fraction which is equal to 1. 60 minutes over 1 hour is equal to 1. So the answer is 0 0.5 times 60 is 30, and 1 times 1 is 1, 30 kilometers per hour. So part B, we want to convert it to meter per second. 0 0.50 kilometers per minute is equal to 0 0.50 kilometer per minute times, we write it up, and we know that 1 minute is equal to 60 seconds. 1 minute, so we can cancel minute with minute. And also kilometer, we know that 1 kilometer is equal to 10 to the third meter. We want to get rid of kilometer, write it down, 1 kilometer 10 to the third meter, then cancel. So the answer of this one is 0 0.50 times 1 times 10 to the third meter over 60 seconds, and that's equal to 8.33 meter per second. Convert the following unit to SI unit. So I have here unit inch per hour, and I want to convert it to SI unit. Inch is unit of distance in American system. In SI, unit of length or distance is meter, and time is second. So I want to convert this to meter per second. So I have 300 inch per hour. I know that 1 inch is equal to 2.54 centimeter. That's what I know. So it's equal to 300 inch hour times, because I want to cancel inch, I write it as a denominator. I know 1 inch is 2.54 centimeter. And hour, I want to cancel hour, so I write it up here, 1 hour, which is 60 minutes. 1 hour, 60 minutes. Now I can cancel hour, up, down, and inch. But now I have centimeter and minutes. I want meter per second, not centimeter per minute. So again, multiply another fraction to cancel centimeter. I know that 1 meter is equal to 100 centimeter. So 1 meter, 100 centimeter. Now it can be cancelled. Also, I have minutes here, but I need seconds. So times another fraction. Minute goes up, so I can cancel it. I know that 1 minute is 60 seconds. So if you keep canceling minute, minute, and centimeter, centimeter, I have meter up and second here. So this one is equal to 300 times 2.54 times 1 times 1 meter over 1 times 60 times 100 times 60 second. And the answer is 0.0021 meter per second. It's equal to 2.1 times 10 to negative 3 meter per second. Test yourself with these problems from OpenStack's physics book. And here is the answer of question number 1 and 3.